We've got a function here called an objective function, this z. And what we need to do is, given these constraints in this feasible region, we need to find what has the minimum value. So we need to make 3 times whatever the x number is plus 2 times whatever the y number is as small as possible. So I'm going to write here, our goal for this question is to make z as small as possible. And the way I'm going to do that is I'm going to substitute each of these corner points into this equation, and I'm going to see where z is as small as possible. Now we know when we've got straight lines that I can use corner points to find my best answer, whether I'm minimizing or maximizing an objective function. The only time that doesn't happen is if I need to use full numbers. But here I've got full numbers anyway, so things are looking pretty good. So let's first of all have a look at point A. At point A, x equals 0 and y equals 12. So that means that my function z will equal 3 times 0 plus 2 times 12. 3 times 0 is x, 2y, 2 times 12, and that equals 24. So therefore, at point A, z equals 24. And I can do the same calculation for each point. So at point B, x equals 2 and y equals 4. So therefore, 3x plus 2y, so z, which is 3x plus 2y, is 3 times 2 plus 2 times 4. And that's 3 times 2 is 6. 2 times 4 is 8. So that's 14. So far, point B is winning. If I need to minimize the value, that's winning. Let's have a look at point C. So at point C, my x equals 4 and my y equals 2.5. So if I want to, I could go into the main section of the calculator and I could say 3 times 4 plus 2 times 2.5 and put that in, and I get 17. So therefore z equals 17. And then for point D, I can do the same thing. So x is 14, y equals 0. So my z function is 3 times 14 plus 2 times 0. And I'll go back here, 3 times 14 plus 2 times 0 equals 42. So therefore, the best place, the minimum value, is 14. And that's how I can answer my question, by substituting in and showing my working out, which I would need to do if this is a show question. If this isn't a show question, however, there's a cute little way that I can solve this, and that's by using my statistics table. So let's go to statistics. And what I'm going to do is I'm going to put in my coordinates of each of the 4 points. So A is at 0 and 12, B is at 2 and 4, C is at 4 and 2.5, and D is at 14 and 0. Then the next thing I can do is say, well, my objective function, which I'm going to call capital Z here, the equation for that, so let's put it in the cal button, is 3x plus 2y. And when I do that, it will do all the calculations for me. Isn't that clever? And what that means is that now I know my minimum value, which is 14. I can just check down my values. There's my minimum value, which is 14, which corresponds to what I've already done. So that confirms that B is the answer.